Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in this NumPy tutorial series into which we will be watching today sampling of data with array and array with different distribution of data. So what these two things are into this our learning roadmap, we'll be getting aware and getting detail of all these uh, um, um, concepts into this particular video. So let's get started with the video. So before moving ahead, let me take you back what we have covered and how we are proceeding ahead. We have covered that what is NumPy. We got aware that what is NumPy. Then we covered that how to create array and how to create different. There are multiple ways to create array. There are multiple type of matrices which can be created with the help of this NumPy. So all these things we have covered up in this create array. So you can take over this particular slide. Today is the turn into which we will be watching that sampling of data, because there is whenever we are having a large data set, we need to sample out the data, correct? So this is a very common technique or common mathematical operation which any data scientist or data analyst do. So to sample the data, we are having multiple ways to sample the data. We'll be watching few ways from it, which is very widely used in NumPy. Then after sampling of the data, we will be moving ahead with the distribution of the data, because whatever data set in front of us we are getting, that data set is definitely been distributed on the you may say line scale, correct? So on a line, if you will map that particular data, you will get distribution of that data. So there are multiple distribution, if you are aware of, there are multiple distribution in statistics into which we will be covering up few of them, but there are multiple more apart from this which we will be covering today. So why we have taken up these particular distribution, because these are some very basic distributions which can be handled or which is getting used frequently into day-to-day activity. That's why I'm taking up these distribution. Going ahead, it might happen that I will again cover up distributions to cover up, if suppose that there will be need to cover up all the other distributions as well, I will cover up them as well. But whatever distributions available into the statistics, all are there into NumPy. And the sampling I have already told you. So these are two concepts today we will be covering up, that is sampling of data. Sampling of data is nothing but taking a subset of the data from a large data set. Okay, so pulling up this subset is only called as the sampling. And distribution refers to way data points are spread. So on a scale, how the data points are spread or distributed across different values. So that only called is as distribution of the data. So now let's take a look. First and foremost is random number generator. So that day we have we saw that how to create array, what all types of different metrics are there, and how to create those metrics. We saw that np.0, np.1, all these things. Today first we will be watching how to create random numbers. Okay, so random numbers, because this is also a very basic need of any mathematical operation. uh, just don't confuse. I'm in a way in which I'm just making you a dots right now, and later when you will be with the series, the those dots will be connected in between, and you will get to know all the concepts why we have covered up. Just right now try to understand whatever I am telling you. So this random number generator is something into which we generate random integer, or we generate random choices. So all these we'll be just taking a look at. So numpy random.seed, this is a very widely used function. So what this seed does, seed is nothing but you are giving an identical number to it. So whenever you are giving identical number and then you are creating the array, then what happens is the array whatever it is getting created randomly will be created uh, identical in each of the seed number whenever it will be given that particular seed number. So better you will understand, let me just take you to this VS Code. Over here what we can show you. So here you can see, right, that np.random.seed we can take 1, or we can take 2, or we can take 3, any arbitrary number you can take. So what's the significance of this seed? So np.random.random, this particular one is generating a array, okay, and array with having the will be identical if you are taking this seed as 1. So whenever let me just execute it. So over here you can see, instead of 10, let me take it 2, so that things will become more easier. So here what you can see, random numbers has been generated with an array of 0.417 and then 0.7203, right? So just take a look at the last digits, that is 22 and 49, right? And again, if you will generate the random numbers, so what you may say, what ideally it should happen. So whenever you are generating random, that it should be random, it should not repeat. That means this 2249, there is very less possibility to repeat it. But since you have defined the seed as 1, so it will generate again the same. But what if you change this seed to 2? So for this particular seed, again the random numbers will be generated, and it will keep on generating same as soon as you are keeping this seed as 2. So this is the way with which you can keep your random generation static. So this is very much useful thing. And if you want to generate random, so definitely what you can do, you can just comment it out. You don't need to provide seed, then just run it. You will see each time the numbers is getting changed. 4 8 and 3 9 is at the last. Here you can see 7 8 and 8 2, then again 6 3 and 9 7. So this is what seed is doing. Hope you got it. After that we are having numpy.random.randint. So this particular one generates random integer from a specified interval. So you need to define the interval. On the basis of that, it will generate the, let me take it a long way, and then instead of this, just put numpy np. This low is equals to, you can provide 1, high equals to, you can provide 10. So 1 will be inclusive and 10 will be exclusive. That means it will be included into your result, and 10 will not be below 10. Whatever the things will be there, it will be included. Let's take size is equals to none. Now if as soon as you generate it, what you can see over here, you can see that this size, since you have not defined, or else you can define the size as well, so that you can get a specific and use 2 of that. So 2 cross 3 matrix we are telling it to generate. So what you can see over here, that between 1 to 10 it has generated random integers, okay, and that is 568475, which is between 1 to 10. And at last time what it was, it has generated 5, which was between 1 and 10. Since size was not defined, so it has generated the integer. So size you can define over here, whatever type of matrix, 1 cross, if you want to generate, you can generate it as well. Okay, 487. If you again provide the seed, what will happen? It will generate identical thing. See, 997, again 997, again 997. If you will change the seed, it will change the combination as well, and it will keep them identical again. 6 696 696. So that's it. After that we are having numpy random choice. So what you need to do is, you need to define the sequence first. That means you need to provide the data set first, and among that data set you need to make a choice of size 3. So what you need to provide is, let me just pull it down here. Fine. Sequence we have defined. Sequence is nothing but a variable we are putting up into the, and after that we are having numpy dot random dot choice, we place is equals to false. So what we can do over here, instead of numpy, np will come, and sequence, since sequence is there over, and then size is equals to 3. That means 3 means subset will be pulled out, which will be having the size of 3, and replace is equals to false. That means it can repeat. So let me just try it. So you can see size equals to 3, so it is pulling out 3 and 4 and 2. It's again 4, 1 and 2. Now what if replace is equals to true? 535. What happened? You got it. That 412, there was all identical number into it. But in this, what you can see, 535. 5 is repeating 2 times. So that only the replace. If you are making replace equals to true, that means it will generate the duplicates as well. And replace is equals to false, it will generate identical number. And size, whatever you want to define. You can even define, hopefully you can define this 1 comma 2. Let's try it out. So it's 1 comma 2, 2 comma 2 now. So you can see, right? 3535, replace equals to true, replace equals to false, then 3145. So all the things are identical over here. So like this you can generate the choice. That means you are taking a subset of that particular data set, which we are again going to do into the sampling of data. So this is more likely to be there into the sampling of data. Now we are having another sampling techniques that are numpy.random.rand, then rand. So all the significances I have just listed down over here. If you are taking numpy random.rand, it will generate random number from a uniform distribution over the interval of 0 1. Okay, after that, generate this rand n will generate random number from a standard normal distribution. Okay, this is normal distribution and this is a standard normal distribution. Mean is equals to 0, mean 0, and standard deviation 1. So these are bit mathematical terms you need to get aware first, that these what is mean, what is standard deviation, and then what is uniform distribution. So distribution, I have told you that it is nothing but if you are taking a scale of 0 to 10, and if your data set is between 0 to 10, that data set will definitely be mapped over there on that particular scale. So the mapping is only called as distribution. Okay, after that we are having numpy dot random size. So it will generate random number from a uniform distribution over the interval of 0 1. So what you can do is, if you will try to execute it, let me just take an example, otherwise you might confuse. So just comment this out, np, and then random size 5. Fine. So what you can see, it has generated the random number. And what is the significance it is there? Generate random number from a uniform distribution over the interval of 0 1. So it is taking up the values but between 0 and 5. And it, since size we have defined as 5, so it is taking 5. If you will define it 15, it will take up 15. Correct? And all the values will be between 0 to 1. Then we are having numpy.random.uniform, into which what we are doing, we are providing low and high and then size. So it will generate random number from a uniform distribution over the specified interval. The specified interval you are defining over here. Here it was all automatically defined. Here also it was automatically defined. And at this particular also random.random, it was automatically defined. If you want to generate on the specified interval, you need to use this numpy.random.uniform, into which you will provide low and high values. After that, we are having a standard normal, which generates random number from a standard normal distribution. So these are few things with which we can have random sampling, numpy.random.normal. After that, we are having distribution. Why I am not going and experimenting with each of them? Because the video might go long, and if you are keen interested, you can just play around with it. I have just put down the specification why it is over there, numpy.random.rand, what it does. You can just go and just do hands-on activity. Definitely you will get to know each and every concept. And if there any confusion you are getting, definitely let me know into the comment section. Now we are having distribution. The distribution is numpy rand into which what we are doing, we are spreading out the data onto some particular scale. So what we are going to do, we are going to do is numpy.random.normal log is equals to 0, scale is equals to 1. So which will generate random number from normal with this specified mean and standard deviation. So let's take this particular one example. Okay, now if you will run it, what it is doing, size, let me define it as, suppose, uh, 3 cross 3, 3 cross 3 matrix. Let's define it. So what you can see over here, that between 0 to 1, that means your scale is of 1 onto which the distribution has been done. The what is the distribution is, so you can see minus 0 point, right from minus 0 to it is taking up till minus 1.55 and 1.99, all these things it is taking up. Okay, so this is just generating the distribution of with this np.random.normal, because it is taking up the Gaussian distribution. After that we are having exponential distribution as well, then the Poisson distribution. So all these type of distributions are available into a statistics which it is taking care of, and there are multiple others as well into which is available into our numpy, with which if you are aware of at how to create this distribution, what is the use of distribution, definitely you can come and then use this particular distribution. Until and unless you are having you are aware of that how this distribution is working and why we use distribution into the mathematical calculation, you will not understand that what this is right now getting done. So you can just get aware that what this Gaussian distribution and all is, definitely you will get to understand that why we are using all this. So this is very simple, into which you can just provide the sizes, we just provide the scale and it will distribute your data set. After that you are having random permutation. So this permutation is something which will shuffle out the data. So these are two ways with which we can shuffle out our data. One is random dot permutation and then another one is random dot shuffle. So it will shuffled, you can just take up an example of np dot array. Okay, original array as this, and then shuffled array as this, and instead of these two, just take shuffled array into the print. Now let's see if it is shuffling. So 1 2 3 4 5 was there, so 1 3 4 5 2 was there. Again you can see that it has again shuffled it up, so all the permutation combination it will try it out. Okay, after that if you want to shuffle, definitely you can shuffle with this particular way as well. So array to shuffle, uh, and then a double r, just run it now. So what it is doing is array to numpy dot array and then array to shuffle. Fine. Ideally it should be something with which, let's remove it out, because, and then just run it. And p dot random dot shuffle, what it is doing is, so first array to shuffle is, we will just print it out. So you can see it is not getting shuffled. So this particular array, it is getting overwritten. So whenever it is getting shuffled, it is getting overwritten over here. So you can see that it is getting shuffled. 1 2 3 4 5 has been shuffled to 2 5 4 1 3. Again it will, if you will shuffle, it will again be shuffled. So you got my point, that how this permutation combination is working, how this shuffle is working. So both of the functionality we are having. you are having the functionality of distribution, then the sampling, and then the random number generators. So all these things were some of the basic need into our whole NumPy learning roadmap. After that, definitely we will be watching more interesting thing, into which definitely there are multiple other things like how to manipulate the array, how to add array, how to divide array. All these mathematical calculation, code mathematical calculation, we will be definitely watching out in upcoming videos. So that was all about this video. Thank you so much guys for watching out the videos, and see you in the next one with some other topic. Stay tuned to the channel. Thanks again.